Everybody. Today's like a little bit of review to for you. Skip this part. So I believe everybody's familiar with this, right?
Mm-hmm.
Just like quick rule through.
Yeah.
Everybody's familiar with this, so we just so I'm not going to spend that much time on that. So let's try the problem about this.
You guys got it?
Yeah, it's just try think of I will give you guys 2 more minutes to think about this.
So it's more like you thinking about what makes x to the power of 7. Look at
power of
4 times
7.
of those stuff. That polynomial right there. What's the combination that makes a 7? We got 1, we got 0, we got 1, and we got 2. The 2 is x over x squared is the 2, is the power of 2, and 2x is power of 1, and 1 is power of 0. So think about how do those stuff. You have 4 things to times together to get to that x to the power 7. But you guys understand what this question means, right? Just make sure that you guys know the question.
Yeah.
Or you guys have problem to understand what the question try to ask.
Okay. Yeah, I don't.
I'm confused. What? Oh, I mean,
it's talking about the expansion of this whole thing, the 1 plus 2x plus minus x squared, and to the power of 4 is 4 of them times together, and you expand them. You learn how to times those stuff to expand them.
Well, it's like when you get all your coefficients just plus minus all the stuff without any bracers, right?
We'll expand them to there's no parentheses anymore.
Yeah, so there's no bracers, you just get out. Right. Okay, yeah. Okay.
Okay, yeah, let's start to talk about this one. We can rewrite this one as sorry. Doesn't look good. So we all know this is we have a power of 4. So you can understand that we are actually multiply 4 variables together. Do you agree with that? We'll just multiply 1, 2, 3, 4. Well, multiply 4 variables together. So in order to get a power of 7, remember, when we are multiplying a variable, we are adding the power together. So which means like do you agree with that? I mean, the n is the power of the variable. So when we are multiplying, for example, like xn1, xn2, xn3 together, that equals x. Yeah, everybody understands this one, right? So in this, since this is a power of 4, which means like 4 variables are multiplying together. So what can we get from here? We can get this, right? Yeah, understand this part, right? So
yeah, it still makes sense. Okay.
yeah, so we know like the n must be a whole number, positive whole number, because when you look back at the equation, what do we have here? We have the x0, that's x to the 1, and that's x to the 2. So which is telling us this is in order to get x to the 7, we need to use those 4 of the variable, 4 of them are multiplying together to get x to the 7. So 7 equals what? 7, what could 7 be? 7 could be 0 plus 0 plus 0 plus 7. It could be 1 plus 0 plus 6 plus 0. But when we look back at the equation, we only have power 2, 1, and 0. So how can we, so 7 could be 1 plus 2 plus 2 plus 2. But 7, it could not be 0 plus 2 plus 2 plus 2. Because the highest power we have is 2. So it must consist by 1 and 2, number 1 and 2. Yeah, everybody understands this one?
Yeah, okay,
Okay.
now it makes more sense.
Yeah.
So good. So we know like, so here we know k 1x1 sorry. So we get this one, right?
Yeah.
Mm-hmm.
So the question is asking what is this volume, the coefficient of this.
You
So
guys
what
get
do
an
we,
answer?
Oh, I got it.
so what do? We put those variable back. Everybody see this? So that would be but this is not the end. We are really close to the real answer, but this is not the end. This is like one of the combination of the equation. So how many else do we have?
4.
Yeah, we could have like, this is like power 1. We could choose this. The first combination is like this, 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 and this. And the second combination is this, 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 this. Do you see that?
Yeah. Like
So-
anyone have a problem in this part? Like how many, how many you will have for how many times when you expand them, you will times those 4 same stuff together to get to a negative 2x7.
Yeah, because we could do like 1 plus 2 plus 2 plus 2 equals 7. This is the first combination we use. And the second combination could be 2 plus 1 plus 2 plus 2 equals 7.
And what are the different, Jackie?
What's the difference? Right. What's the difference between this?
If you look this back, you are multiplying like this. The first combination is multiply this to this, then to this, then to this. The
Right.
second combination is multiply this to this, then to this, to this. Do you see the difference? You are
No,
multiplying.
it's like the same stuff.
Yeah, they can get the same result.
Yeah, so we have, which means we get the same result 4 times.
Because we expand them. We
Yeah,
expand
when we
every
are
possibility of combination will be used. If you do the expansion before, you would every variable in each parenthesis on each parts will be times to each of the others, because that's how you expand them, right? If you try to
Yeah,
do
like,
3, you can give example, Jack. You can give an example to them to show
yeah,
why,
like just
why,
do
why
an
that's true.
easy example. Like 1 plus 2x multiply 1 plus 2x.
Probably
How do we
probably 3.
expand that? Like we multiply this together, 1 plus 2x plus 2x
Okay.
plus 4x squared. See that? Get this, Claudio? That's how you expand that.
Yeah. I know what
You
you're
use
talking
the
about.
first
Yeah.
number multiply second number, then you get this one.
Mhm.
So like same concept, we could have like 4. We could have 4 combination of this, which means here, like if we multiply here together, we get like -2. So we multiply this. So we multiply the result by 4.
Because we will have
Because we have
of the
4
identical
combinations.
ones. Yeah.
So get this. So that's why we have final answer -8.
Now, could you explain once again why is it -8? Okay, I got the part of -2x and power of 7, but like, why is it -8?
Yeah. So like, it's just like when we are expanding a equation, like a plus b plus c plus b plus c. Let me think how to like use that. So what we do, okay, let's use the easier version. So like when we are expanding an equation, what do you do?
Like multiply each member of 1 times 1 plus 1
Okay.
times x plus minus x squared, and like do that with each member.
Okay, so let's do an easier version. So for this time, I only ask you to find, let me see, x to the power 3. So in order to find x to the power 3, let's just expand because this is easy to do that. So what we do, we 1 multiply 1 plus 1 multiply 2x minus 1 multiply x 2. See, that's how we expand, right?
Yeah.
So in order to find x to the power to the 3, we multiply this together, right?
Okay. Yeah.
We will have some step like 2x multiply negative x. Then we plus.
Okay. Yeah.
See, there are like two combinations here.
Yeah.
This multiply this and this multiply this.
Mm-hmm.
So you add those together. It's actually just like 2 times. Because we have two combinations, so we just multiply this by 2. So we have like,
Oh, okay.
yeah, did you get
Minus
my idea?
4 is our final answer, right?
What?
Minus 4 is our final answer.
Minus 8, because we have like 4
I
combinations here.
just about this example here. Yeah, it's minus
yeah.
8. Yeah.
Yeah, minus 4 is our final example. It's final result.
Mhm.
So you get the idea like of the combination, right?
Yeah.
So we have 4 combinations here. So we just like multiply this by 4.
Yeah.
And we get negative 8.
Okay.
Everyone good?
Yeah.
Yeah, but I mean, why we have to multiply 4 again?
We have 4 combinations. We
Yeah,
have
Why?
like
Because
4.
they're all the combinations.
Oh,
How we do the expansions, right?
Yeah, it's because of those two. 1 plus 2 plus 2 plus 2 is the first. 2 plus 1 plus 2 plus 2 is the second. So we have like 4 of them. And we know that the result is the same. So that is why we can just multiply it by 4.
Yes, that's exactly what we are doing.
Yeah.
Yeah.
Okay.
So everybody get this idea? Okay. You probably learned that in algebra. Yeah, so it's just like a quick review for that. So like an example of the sequence is like 1, 3, 5, 7, 9.
Yeah.
Yeah, everybody understand this sequence, right?
Yeah, but what's the n? Just Jackie, could you explain what's the n, what's the d in this example you gave us?
So in
Or-
this example, n is like the order. It could be the order or p could be the sequence. Like for example, n equal 1 means the first number in this sequence. N equals 3 is the third number in the sequence. Yeah, understand this? Okay. So D is a difference between those two numbers because we can say each time it increased by 2. So D is positive 2. So we have the equation, like for example, if we want to calculate the 7, the value of 7, what we did is like we use A1 which is the first number, plus we want to try to find the value of the 7th number. So times the difference, which is 2. So number 7 is 13. Everybody get this?
And you can count that like 11. The next one is 13, which
Yeah.
is the 7th one.
Yeah. Which is, yeah, it's just like a review full form like algebra. So what happens is, if we are going to add all the number together, for example, like we are adding all the number together. So what we do is like we add the first number to the last number, then multiply how many numbers there are, 1, 2, 3, 4, 5, then divide by 2. Yeah, everybody understand that? You probably, I'm pretty sure you learned that before.
Okay,
It's
good.
quite simple.
So let's look at the next one. Geometric sequence is a little bit different. It's like 1, 3, 9, 27. You can see each time they are multiplying a number together. Like multiply 3, multiply 3, multiply 3. That's geometric sequence. Common ratio is, oh, I should not use that. This is a common ratio, 3. See, because each time we multiply 3 between those two numbers. So, yeah, as like n is like the nth term. You already know about that. So let's see, like if I want to find a5, which is 3. N is 5.
Yeah, and you can see yourself that 27 times 3 is 81.
Yeah, see that's how you get this.
And the sum.
So, yeah, so when you are adding them together, it's like, so if I want to like add those, let's use those 4 together. If I want to add those 4 together, I use the first one, multiply 1 minus 3 to the 4, because there are like 4 numbers here, divided by 1 minus 3. If you do add them together, you get 40 here too. It's just like a shortcut for you guys to do about this.
Okay, good.
Yeah, I very good with that. So this problem is a little bit challenging because it requires you to think about all the possible results, all the possible outcomes it could be.
Do you want to make sure that everyone understands this question first?
Yeah, just like read the question first, then ask me if you don't understand some part of the question.
What is tossing a die mean?
用骰子。
Oh,
1 to 6.
Not done.
okay.
Each
Okay.
one have a square.
You got this.
Yeah.
I got it.
Nice. Yeah.
Actually, this require a little bit like concept of calculus.
Calculus. Really, Jackie.
Yeah, if you think about this, Evan, when a ratio is smaller than 1, and that infinity is going to be close to 0. That's a calculus thinking it required here.
Kind of, yeah. I would say it is a little.
Yeah.
Okay. I think I kind of know this one.
It's so weird.
Okay.
I think I should introduce another example before this question. Okay, so I will think about like something. If something's sequence can go to infinity, if something can go to infinity, I will think about that like, in this question, it can go like, for example, a sequence is going to like multiply R, A1, A2, A3, and it has like infinity. So now let's think about this. If the ratio is closer than 1, sorry, it's less than 1, we have the sum equation. Then it's like, it's going to be infinity. Remember, if R is less than 1, for example, like 5/4, its infinity power is going to be 0. It's going to be really, really, really close to 0. Claudio, you know this, right? You learn from calculus.
Right.
As n approaching infinity, R to the n, let me rewrite.
Wait, I thought there's a special ratio. I forgot if I learned it wrong. I think there's like a special ratio that like a half or something, or that's for anything that's smaller than 1.
Oh yeah, but I'm not asking about this one. I'm only saying about this.
Okay.
Yeah, it's only I'm only looking at this part. I'm not saying about this part yet. I'm not talking about this part. I'm only talking about R infinity. I'm
So
only
what
talking
is
about this
R
one.
in this question mean?
R means the ratio.
Oh, ratio.
Like
Ratio.
three, like for example, we have a sequence 1, 3, 9,
Oh,
27.
I got it. Mm-hmm.
R is the 3, like how
Right.
much they multiply after each one. So if that R is less than 0, it's less than 1, and the R to the infinity is going to really close to 0. Right?
Yeah.
So let's put that back to this equation. So which we have like 1 minus something approaching to 0, which is 1 minus 0. That's only for all less than 1. So that's a new equation we get for this.
So Jackie, is the I forgot, is the question, is the, oh no, the answer is wrong. I was trying to solve it first.
Oh, that's not for the question. That's just like I'm showing them like the calculus thinking they need in this question.
Okay. Is the answer 3.54%? That's what I got.
25 over 91.
25
I need a
over
calculator.
negative what?
91.
91. Okay, let me do it.
Yeah.
91.
25. Yeah, 91. 0.2747.
Wait, why is that time? I got 20. I got 25 on the top, but I didn't get. Okay.
And like it seems too big. Think about this, like 30% chance of being the first one to get 6.
Yeah, so okay, let's look at this question now. So let's say like let's think about that. What's the possibility for him to for this guy? I call him like Mr. C. What's the possibility for the Mr. C to be the first one to the 6 in the first round?
You'll be 5 6 times 5 6 times 1 6, right?
Yeah. Then we need to add the possibility that nobody gets 6 in the first round, but he got 6 in the second round. So let's add like, which is nobody gets 6 in the first round, which means, and they begin the second round. That's A didn't get 6. The possibility A didn't get 6. Multiply the possibility Bob didn't get 6. Then multiply the possibility he got 6. Yeah, let's just rewrite the equation.
So do you guys see this a geometric sequence every time we add
like,
a possibility of next round that someone that C got told 6, which means you'll be the last round, the possibility of the last round times 3 6 5. If you already see that pattern, but you can do more to show that. But if you just look at the next one, the second round, Jackie just write down, it will be like, I think, times 3 more 5 6. That's the possibility of C didn't get the 6 in the last round, and then in the next round, A and B didn't get 6. So it will be 3 of them.
How did you get like 5 over 6? Why is it not like, what is 5?
Yeah, because what happened is like, how many possible value for a toast? For a die. We have 6. Yeah. So what's the possibility it is not 6? 5 over 6.
Okay, 5.
5 over 6.
About not 6 if we're talking about 6. Isn't it just 1 over 6?
No,
I mean,
you'll be the possibility of 1 toasting a 1 and 2 and 3 and 4 and 5. So you just don't need to, like, the possibility of not 6 is anything other than just 6. So you toast any other size fine, just not 6. So this 5 of the 6 chance you will get other stuff other than 6, other number, and there's only 1 times the possibility you will get 6, because
Yeah,
there's
we have 6 outcomes. The possibility that it is not 6. Oh. So we have 5 out of 6. It is not 6. You know about this, right?
yeah, just.
So
I
while we
just,
are seeing,
it just seems that possibility should be lower, but somehow 5 over 6 just, it's not going to decrease 1 over 6 significantly. So that is why I'm like, is really the probability that high of only Carol getting that 1 over 6?
Okay, that's come up.
well, yes, that is like, for example, like me, Evan, and you are toasting or die. Like the possibility I didn't get the 6 is 5 over 6. Then multiply Evan's possibility, which is also 5 over 6. Then multiply your possibility to get a 6 is 1 over 6. If you multiply those together, 5 here is 25, 36. That's a possibility you get 6. It is
25
not
over,
high.
yeah.
Yeah,
So it will be
25 over
very
200, and it's only it's a little bit above 10%. So you see, and this is the possibility is less than 1 over 6.
Okay.
So you see, it is not a high possibility. It's only a little bit above 10%. So let's keep going. I know this is a tough question. So, but we also have another possibility is like, what happens if he didn't get, nobody gets 6 in the first round, nobody gets 6 in the second round, but Mr. C got 6 in the third round.
I have to add that possibility too, right?
Yeah, we have to add that possibility.
Do you guys understand why each time we'll only have 3 more 5, 6 times into this new term from the last term of this geometric sequence?
Yeah.
Like 1, 5, 6 is because of the last round C didn't get a 6, and the next 2 is the possibility that A and B in the next round didn't get a 6. So that's why we have 3 more 5, 6 times into the new term.
Yeah, let's rewrite this one. That it could be 5 over 6.
So maybe we can, Jackie, maybe we can now start to build our geometric sequence.
Big. You know, this is like from this, add this, add this. Yeah, I don't have enough space to do that. So did you see, then we can add like, then the next one is like 5 over 3. Then we have infinity. We have infinity here. Did you see the sequence between this one and the, sorry. Oh, did you see the sequence here? Geometric sequence?
Everyone see the sequence here?
Mm-hmm.
Yeah, so did anybody find the ratio, the common ratio? So what are they multiplying each time?
6.
Power 6 and power 3.
Yeah, this is a ratio anybody find like.
Right.
And this is A1.
A1 is the
Okay.
constant that every sequence has, right?
Okay, yeah, let me rewrite the equations to help you guys to understand this one. As we did. We have this, right? So let's just rewrite the whole equation. Yeah, because here is like, sorry.
Yeah, okay.
Did anybody see the sequence here? If we rewrite the whole equation.
Okay, I'm good. Anyone else have problem?
I'm good.
with the sequence?
It's fine.
I'm good.
Okay. So let's build a sequence now, Jackie.
Yeah, so we found that the ratio is, that's the ratio, right?
Yeah.
Let's just put that back to the equation. Oh, let's see, since this can go like infinity round, you have infinity possible rounds here. So n is going to be infinity. It's going to be 0.
Because that 25 over 2 ones, whatever, that 125 over 216 is very,
Yeah,
is
because for
smaller than
example,
1.
like every time when you multiply 1 over 2, you get 0.5, then you multiply 0.25, 0.125, then you will get a number infinity close to 0.
Mhm.
Yeah, get that. So as long as the ratio is less than 1, the infinity is going to be, the power of infinity is going to be 0. So which is easier? We only like, let's just like put this in the equation. What's A1?
Did you remember this A1 over 1 minus R is how is what we have derived before when talking about that is 0.
Yeah, that's,
So that's
what
why we
we
don't
do
have
on
that part in this new equation we derive. This is a hard question, guys. Don't get like very destroyed because
yeah,
this is gonna be,
a
to do it. This
really
is very
hard one.
good. This is a very, very hard question. I mean, for us, I would say it's not something in your math test.
I need a calculator.
91.
Yeah. If you do the calculation here, you get, then we cancel this. Then that's a possibility.
Yeah, I did it wrong in the beginning because I thought there's only 2 more 5, 6 in the next round, but there's 3 because I forgot to times the possibility of C in the last round to not toast a 6, and that's the reason why I got it. So there's many things you can get wrong in this one, even though you might know how to solve this question.
Yeah, this is like a really hard question. I mean, just like spend a few days to understand.
I have a question. Why do we summarize the probabilities of our first trial and then second trial? Shouldn't we like continue multiplying by 5 over 6?
Yeah, well, because those situations are different situations. They are independent situations. I mean, if you toss a 6 in the first round, so you don't have to toss a second round. So do you say they are like a different situation? So they are independent from each other.
To be
Did you
honest,
get my idea?
this is why I think it's hard to understand this.
Yeah, but like in the problem, it is said that alias follows Carol, so they're like saying that their actions are looped, so they like go over again.
I know, but think about it. Think about the key. The way how I understand this is that we will do the next round. The possibility you calculate for the next round doesn't really relate to the last round because that's the only one possibility. Like in the second round, the first round doesn't exist. Like I mean, the first round, the second round doesn't exist. That's why the first round doesn't affect the second round. It's kind of a little hard to understand that, but there are different things. Even though we did use the possibility of the last round to calculate the next round, but they are not the same possibility. They are not dependent events. We'll say it's like a statistic knowledge, which is I got a little hard time to understand that too. So I know how I feel about this.
Yeah, so when we are doing a question, we see how many situations this have. We have infinite situation here. Like for example, it finished with the first round, second, it finished with with 2 rounds, finished with 3 rounds, finished with 4 rounds. And you see those situations are independent from each other because you can't have both at the same time. You get this? We can't have them we can't have both at the same time. So if like 2 situations are independent, the possibility is going to be easy to calculate. We just add the possibility of the first one.
Okay.
We just add them together for the whole possibility.
Very good explanation. That's a very good explanation. Do you see that now, Key? Like or mute, but
I think
okay.
Actually, I think because we're multiplying by the probability of our previous round. That is why we just like can summarize them because our factor is the same for each round.
Yeah, but there are different situations. There are different, you will say, parallel universe or whatever, you know.
Okay, I get it.
Okay.
Okay.
Cool.
So I think that's all for today.